Dear Professor, my name is Ngo, and today I'll be presenting my project. And the topic is a comprehensive analysis of machine learning algorithms for intrusion detection systems using NSL-KDD and IoT telemetry datasets. So now let's begin. So here is today's roadmap. And this project tested seven machine learning algorithms on two cybersecurity datasets, NSL-KDD and IoT telemetry. I optimized them with hyperparameter tuning and evaluated using accuracy, recall, F1 score, and false positive rate. And results show SVM was bad on NSLKD with about 77% accuracy, while Random Forest led on IoT with 87%. Overall, the tree-based algorithm can outperform linear model, providing practical benchmarks for IDS research. So, moving to introduction, cyber threats are becoming more complex, making intrusion detection system essential. Traditional signature-based IDS can detect known attacks but fail against zero-day threats. Machine learning addresses this by learning patterns from traffic and behavior data. The study tested seven algorithms, tuned them systematically, and compared results across both multi-class NSL-KDD and binary IoT datasets, aiming to give clear insight for real-world IDS design. So moving into literature review, IDS research shows two main detection types, signature-based and abnormally based. Machine learning, especially classification methods, has been widely applied. Recent work highlights the success of enables deep learning, and hydras. The most common datasets are NSL-KDD, which includes multiple attack categories and IoT telemetry data, which capture device and sensor behaviors. This form the basis of our evaluation. So moving into methodology, we use two datasets. NSLKD include 41 features, 5 classes, 125K training, and 22K testing records. For IoT telemetry, it's 17 features. It's about 401K samples, binary classification. So I apply pre-processing, encoding categorical features, scaling, and removing redundant ones, and splitting into training and testing. Algorithm tests are random forest, KNN, logistic regression, SVM, ADA boost, decision tree, and naive Bayes. I tuned hypermeters using grid search with threefold cross-validation and evaluated performance on accuracy, precision, recall, F1, FPR, and confusion matrix. And now moving into the results of the NSL-KDD. On NSL-KDD, the best performance was FVM at 76.9% of accuracy, closely with K by followed by K-name and decision tree at around 76%. Random Forest achieved 75%, while other boost and logistic regression trailed slightly. The key findings are non-linear models outperformed linear ones, but recon remained low around 50% due to poor detection of rare attacks like root to local or user to root. All models detected DOS attacks well, but was the easiest to classify. So moving on by attack categories, breaking down by attack type, benching traffic and DOS were detected with high precision and recall. Probe attacks were moderately detected. Root to local and user to root was the hardest, with recall often below 10%. This highlights how class imbalance and variety of samples make multi-class intrusion detection much harder. So for the IoT dataset, results were stronger. Random Forest achieved 87% accuracy, with KNN and decision tree close behind at about 86.5%. Naive-based logistic regression and SVM performed quicker, around 69% to 70%. The key takeaways are that binary classification is simpler, leading to higher accuracy overall. The tree-based algorithms capture sensor correlation effectively, while linear models had low recall but very low false positives, which can be useful in strict systems. So, looking closer, moving into IoT detail performance. RF and KNN offer the best balance of precision and recall. Decision tree was good but had more false positives. Net-based were fast but unreliable for detecting attacks. Logistic regression and SVM produced very few false positives but missed many attacks. So the choice depends on whether the priority is catching attacks or minimizing false alarms. So, comparing across the datasets, IoT consistently outperformed NSL-KDD due to binary labels being easier than multi-class. Random Forest and Canaan were strong in both datasets, showing robustness. Non-linear models methods were generally better than linear ones, and feature complexity mattered. For NSL-KD 41 features were harder to model compared to IoT 17 similar features. So, moving to benchmark comparison, I compare results with recent IEE studies. For NSL-KDD, my SVM and KNN slightly exceeded benchmarks. Decision tree also outperformed, while rainforest was slightly lower. For IoT, rainforest, KNN, and decision tree on outperformed published benchmarks, while neighbors, logistic regression, and support vector machine were comparable. This shows my systematic reprocessing and tuning led to comparative and superior results. So, um, from my analysis, here are the guidelines. For high accuracy, Prana Forest, KNN, and Decision Tree. For real-time use for name-based, logistic regression, or SVM. For interpretability, Decision Tree, or logistic regression. Data type matters. Multi-class is harder in samples, while binary IoT data favor similar models. So hyperparameter tuning was critical. For example, random forest work best with 200 trees, and support vector machine need an RBF kernel on NSL-KDD. So in practice, random forest balances performance and efficiency, but models like KNN are computationally heavy. So to wrap up, rainforest and canyon were the most robust performance overall. IoT outperformed NSL-KD because of similar binary classification. Hyperparameter tuning improved accuracy by up to 10%. Trade-up is a linear model are fast but less accurate, while tree-based models are slower but more balanced. For practice, you brand forest or canyon when accuracy matters, NB or logistic regressions when speed is critical. Looking forward, deep learning, adaptive models, and adversarial preparedness are promising research directions. So here are my reference list, including surveys on IDS, machine learning in cybersecurity, and recent benchmark studies. Thank you for your listening.